Today I will be presenting graphing y equals sine of x with examples and explanations by Nhan Tran. So first, you want to use a unit circle to convert the degrees into radians, and to do that, you have to multiply the degrees by pi over 180. So we'll be using the red points here, 0, 90, 180, 270, and 360. So those are the 5 points that we will be graphing later on. So this is a table of the degrees converted into radians along with the sign. So 0 is still 0, 90 is now pi over 2, 180 is pi, 270 is 3 pi over 2, and 360 is 2 pi. And I got this by multiplying by multiplying the degrees by pi over 180 and then simplifying. And then the radians are now the x-axis, while the sine is the y-axis. So this graph is a trig graph with the x-axis converted into radians, and the y-axis is still whole numbers, which is your sine. So this is the graph with the x and y graphed correctly: 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. This pattern here, this S shape, will continue as you keep going with your graph, whether it's forward or backwards, and this X shape will always be used when using sine, with 3 points on the x-axis and 2 points either going up or down, either way, because this can be flipped depending whether it's a negative, but the pattern will always remain the same. The domain of y equals sine of x is all real numbers because we're graphing on a Cartesian plane, or the x and y graph, which can only hold all real numbers, and imaginary numbers can't be graphed because they go beyond the graph, so only all real numbers can be used. And the range is -1 is less than or greater to y, and y is less than or greater to 1, which is shown here, where the highest and lowest point is 1 and -1. So the y can be anywhere between those points, but never above or below those. And so the domain is all real numbers, and range is -1 is less than or greater to y, and y is less than or equal to 1. So for my example, I will be doing y equals 2 sine of x. So this is my example, and this is the original, and you can see the only change here is the 2, where the invisible one would be. So the 2 is in the amplitude. In the formula here, y equals a sine parentheses bx minus c parentheses, and the amplitude affects the a in front of the sine, and the amplitude is it's deciding the height of the peak or the trough of a function. So basically that means that the amplitude changes how high or how low the graph will be. So with the 2 replacing the 1, you will multiply the sine by 2. So 0 times 2 will still be 0, and 1 times 2 is 2. -1 times 2 is -2. So that's what the changes here mean. And the graph, the blue is the original, y equals sine of x, while the red is y equals 2 sine of x, which show the changes that the 2 made. So the x-axis points stay the same, 0, pi, and 2 pi, they all stayed the same where they were before. The only changes is how high that these points went. Instead of just going up to 1, they went to 2 and -2, which is the only changes that were made by the 2, or the amplitude of 2. And this pattern stayed the same in the S shape, and only the height changed. So the amplitude changes the height, and depending on what number you use or are given, will decide on how high or how low that graph will go. Thank you for your time, and thank you for listening.